Welcome to the debate. Today, we're focusing on something that I think really challenges our human-centric views of cognition, and that is the communication systems of birds. The sheer complexity of their songs and signals forces us to question what's really going on there.
Absolutely. It's a system that's just full of strategic brilliance. It's optimized for survival in ways that, well, they rival almost any other organism.
Right, so that brings us to our central question today, which is really about interpretation. Does the evidence, and I'm thinking about things like song learning, geographic dialects, and just the staggering capacity for mimicry, does all that suggest that bird communication is a flexible, intelligent system? Something almost like cultural transmission? That's the side I'll be taking, that this is about learned behavior and cultural adaptation.
And I'll be coming at it from a different angle. Look, I acknowledge the complexity, of course, but I believe the system's effectiveness is fundamentally rooted in highly optimized instinctual behaviors that are driven by very specific evolutionary pressures, survival, territory, reproduction. I think the learning we see, it's a mechanism for perfecting an instinct, not for genuine innovation.
The thing is, the sophistication here just can't be explained away by simple instinct. It's defined by its adaptive intelligence, and the strongest evidence for this is, it's found in the mechanism of song learning itself. This isn't just a bird making a noise, right? It's a whole process. It requires a sensitive period where a young bird has to listen to an adult tutor to get the acoustic template, and then they spend weeks in this sub-song phase, which is a lot like human babbling, before they start refining it. The entire process is governed by specialized brain regions, which shows a huge cognitive investment that's designed specifically for flexible learning.
And beyond that, you have the existence of these distinct, stable dialects that change based on geography. That's indisputable proof that these vocalizations aren't just static or purely genetic. These song traditions are passed down socially. That is a powerful form of cultural transmission. If the system were just instinct, you'd expect one single genetically fixed template everywhere. The fact that the template changes and relies on social tutoring, that proves it's adapted through experience. Even the genes involved are analogs of human language genes, confirming the whole infrastructure is built for learning.
That is a compelling point, and you're focusing on the mechanism of production, but I would frame the purpose of it all very differently. While the mechanisms for mastering sound are elaborate, and they have to be, given how competitive their signaling is, the function and the actual output remain highly specialized. They're fundamentally tied to immediate evolutionary fitness. So what we're seeing is a highly optimized instinctual strategy, not some kind of open-ended language.
But the learning is so intensive.
It is, but think about the immediate utility. Songs are used very explicitly to attract mates, to signal good health, strong genes, and to defend territory, with clear, unambiguous warnings. The purpose is strictly functional. And then you have the calls, which are even more revealing. These are brief, highly specific messages for day-to-day survival. You have alarm calls, contact calls for the flock, begging calls from chicks. The material points out that some alarm calls are incredibly specific, right? They don't just say predator. They can signal the type of predator and its danger level. That kind of specificity suggests hardwiring. It prioritizes a rapid, unmistakable response, which is exactly what evolution would demand. And let's not forget the visual signals, the bright feathers. Those are fixed, inherited signals of health and aggression. The whole system is built around executing precise, inherited scripts.
Okay, I see why you prioritize the immediate evolutionary function, but let me bring it back to the learning process and what I'm calling cultural transmission. The fact that a juvenile bird has to spend months practicing, refining its song, and that these vocal traditions are socially inherited, that all points to a non-instinctive cultural process. To say the learning mechanism is just perfecting a fixed template, I think that really overlooks the reality that the specific structure of the song, the local dialect, is environmentally determined and socially passed down.
Right.
If the goal was just perfecting a template, why the need for a sensitive learning period? Why the intensive social tutoring? It's because the ability to transmit and acquire locally optimized information is an incredibly adaptive strategy.
A local song variation might attract more mates or repel rivals more effectively. And social learning passes that adaptation down far faster than genetics ever could. It allows for rapid cultural evolution, not just executing a pre-programmed script.
I'm sorry, I just don't buy that the variations we call dialects represent some fundamental cultural innovation. The practice that's required might simply be the neuromotor development needed to hit very precise acoustic markers. Think of a human learning a complex motor skill, like balance. It takes practice, but the underlying goal and function are fixed. These so-called dialects could just be minor acoustic variations that are optimized to cut through local environmental noise or to make sure birds recognize their own species in a crowded soundscape. They're tweaks on a genetically encoded framework, not some kind of new idea. The key difference is that birdsong lacks semantic displacement. It always refers back to the here and now, mating, danger, territory. And let me just reintroduce the rigidity we see across the entire system. Think about the chickadees. Their chickadee alarm call actually encodes information about predator size and threat level in the number of D notes. That's a rapid, hardwired response that's indispensable for survival. It suggests that immediate utility is what fundamentally dictates the structure. We see the same thing in non-vocal signals. The bright, genetically determined plumage in courtship displays. That's a fixed, inherited signal about fitness. It's not subject to practice or local dialects. The flexibility in acquiring the song seems to be completely enslaved to a fundamentally fixed evolutionary strategy.
That's a powerful argument about the need for rapid signaling in life or death moments. I'll grant you that. But if the entire system is so optimized for these fixed functions, how do we account for the radical flexibility we see in species that mimic? Lyrebirds copying chainsaws, starlings mixing in city noises, parrots learning human words. This proves the vocal apparatus is capable of so much more than its immediate hardwired survival needs.
Right.
That capacity for mimicry suggests the brain isn't just optimizing a template, it's processing and strategically using complex non-biological sounds from its environment. Why would an optimized survival machine need to perfectly replicate a car alarm? It has to be fulfilling complex social functions, maybe confusing a rival or signaling superior cognitive ability to a potential mate. That points to an intelligence that is strategically manipulating its environment through communication. And that is the very definition of an adaptive intelligence system.
I fully concede that the phenomenon of mimicry is astonishing, but I would caution against attributing open-ended meaning to it. This mimicry might just be the ultimate expression of that instinctual drive for high-fidelity signaling. If a male lyrebird incorporates a really complex, unusual sound, like a camera shutter, it could function as what we call a supernormal stimulus. It's an exaggerated signal that's highly attractive to a mate precisely because it proves superior motor control, superior cognitive processing. So the intent is still fixed, attract a mate. Even if the content is flexible, the flexibility just serves the hardwired goal more effectively.
And this leads right back to the brain itself. The specialized regions for learning and perfecting songs are enormous in these species, relative to their brain size. That's a huge metabolic and cognitive investment. It's not just about motor control. The anatomy of the connection suggests strategic cognitive processes are shaping what comes out. This strongly suggests that language, or something like it, isn't just a human trait, but that evolution drove a specific type of learned, cultural communication in birds to help them adapt.
I agree, the investment is substantial, but I maintain that the complexity of those mechanisms is required for the high-fidelity execution of a vital survival script. The existence of these specialized brain areas just demonstrates how evolution prioritized sophisticated vocal performance. It doesn't prove the system can generate new meaning, that the birds can use those learned sounds to, say, discuss something that isn't right here, right now. And until we see evidence of that kind of semantic displacement or real grammatical complexity, I have to view the system as a highly refined evolutionary tool serving a pre-programmed behavioral mandate.
So our discussion really confirms that avian communication is. It's characterized by this deep sophistication and a high adaptive capacity. My core thesis remains that the evidence, the required learning period, the cultural transmission through dialects, and the flexible intelligence shown by mimicry, it all overwhelmingly points toward a communication system that's actively shaped by experience and cultural adaptation.
And my argument is that while, yes, these learning mechanisms are complex and present, the overall architecture remains structurally fixed. It's overwhelmingly oriented around very specific, vital evolutionary functions: territory, survival, and reproduction. The complexity serves to optimize the execution of those instinctual strategies, not to create some kind of open-ended sharing of cultural concepts.
We can both agree, though, that the sheer elegance of the system proves a high level of adaptive strategy is involved.
Absolutely. Whether it's driven by flexible culture or by optimized instinct, the material reminds us that every single chirp, flutter, and melody contains sophisticated life or death meaning.
Which just shows us there's so much more strategy and potential for cultural understanding to explore in the avian world.